Okay, thanks. And welcome to this presentation on best practices in implementing live and synchronized OTT services. And we're also going to talk a little bit about OTT business models when it comes to live OTT. So with me today, myself is Per Lindgren. I'm responsible for live OTT services in Net Insight. And we're going to have a shared presentation. So Matt?
Yeah, Matt Skirping from TATA Communications, Media and Entertainment Group, based out of Los Angeles myself. So.
Excellent. So let's start. So agenda, we're going to look a little bit on trends and challenges, especially when it comes to live OTT and live services over OTT. Then we'll look a little bit into when implementing platforms for live streaming. How can you optimize that, and what are the challenges today? We're going to look at a solution called Psy, which is really truly optimized for live streaming and ultra low latency. And we're also going to look a little bit on new monetization and business model when it comes to live, because when you have a low latency model that can really come down to this low delays, it also open up some new revenue paths. So we'll look a little bit into that, and hopefully in the end we'll also see a small demo here. So we heard a lot about the increase, of course, of OTT services. We heard it on the panel session before, and also in the Roku speech this morning. What's also interesting is not only OTT itself is increasing, but this is actually figures just recently from the Nordics, that how much percentage of the content viewed is actually live. So if you go back 3 years, it was below 10%, but it has increased now, and last year now it was 18% of the content watched in the Nordic countries was actually live content. So we do see a big increase on the live side. And of course, we had big events this year. We had the Olympics, we had the FIFA soccer tournament that has huge audiences looking into it. And we can see now also with the election, a lot of people viewing the election here in the US across OTT. But what are the challenges? Well, of course, the obvious one and the one everyone's talking about is latency. And in a report from last year with Unisphere Research, said reduced latency is the most wanted OTT improvement. And it says it breaks social interactions, spoils the excitement, and makes enhanced second screen experiences difficult. Yes, latency is definitely important. And when we're looking at today's platforms, where do the latencies sit? Well, out after the transcoder, where you get the different ABR profile, it starts to go into the packager, where we chunk up the video into chunks. So, and here typically is the first part that adds delay to the OTT service. And typically we're talking about one to two segments of delay, sometimes even more, depending on the implementation. So in a typical default implementation of where you have chunk sizes or segment sizes of 10 seconds, well, then it typically adds 10 to 20 seconds of delay. Of course, you can optimize this by taking down the chunk sizes to typically in HLS, the minimum today is 2 seconds. So then you can reduce this. Then you go into the actual CDN infrastructure with the origin cache and the edge caches. That actually doesn't add too much delay, but it does add a couple of seconds of delay. Of course, again, depending on the infrastructure and the architecture of your CDN network. Then the other big thief here is definitely on the client. And typically, if you look at HLS, for example, it stipulates that you need to add 3 segments of buffering in the client. So of course, if you have the default value of 10 seconds, that adds another 30 seconds. So typically, the typical value here adds up to around 40 to 50, perhaps 60 seconds. That's typically what you see when you start a normal play service. It's typically somewhere between half a minute to a minute behind the normal broadcast you see on normal television. The other thing is synchronization. So this is typically startup delays when you start your play service. Then after a while, especially if you're looking at long tail content like sports, where you're watching perhaps an hour or 2 hours, after perhaps half an hour, you might have added another minute to your delay. So even if we started same time, depending on the infrastructure and the packet network conditions, you can add significant delays from the startup delay. And in HLS, it stipulates the maximum delay you can add on the client side is 15 minutes. And actually, we've had some clients that have seen this type of delays when it comes to live sports. And of course, why is then the delay and the non-synchronized delivery important, or a challenge, or an issue? Well, one thing is, of course, the social. More and more people, and you can see this in most of the reports, that a lot of people today, when watching, especially live content, are also at the same time engaging in social activity. That can be anything from Facebook to chatting or emails or Twitter. And this is from last year's Super Bowl Sunday. You could say there was 28.4 million tweets during the game time. And it was over 185 million Facebook mentions during game time. If you add all the chat and line and SMS messages and emails going back and forth, and you remember also last year's Super Bowl, that really was very exciting up to the last minute. That could really spoil the whole event if you got an SMS or text message before you actually seen it on your device. And so it's all very much about broken social. And we have talked very much that if you look at the early days of the television, of course, there were more like campfires you were watching together with your family and friends. The last couple of years have been more binge viewing. We talk about the digital loners, watching your series alone. But people are social, especially when watching live content. They want to interact with other people. And when we're also talking to the programmers and the production companies, they also want to interact. They want to engage the audience and they want to interact. Again, that requires a low delay and also a synchronized delivery, because otherwise it's hard to do the interaction and the interactivity in the content. Of course, the other big thing I think when it comes to live, and the obvious one is scalability. I'll not go into that, but of course the biggest viewing figures you've seen is on the big sports and big events where you can have millions of people watching at the same time. Quality is another big thing, but when it comes to live, it's not only just picture quality, even though I think when watching, especially sports and live, people are less willing to accept poor quality because it's very important. But there are a couple of other things. It's things like startup times becomes more important when watching live and linear, especially if you're switching between different channels and different cameras or different content streams, which is more common when watching live than just when you're watching a series or a film. Then you start once and then you watch it for a period of time, and then you switch to another content. But if you have a more live linear experience, the traditional thing in a normal linear viewing experience is you want to switch between the channels. And if that takes a long time to switch between the channels, it also doesn't give you a very nice live feeling, right? And it's not only startup times, which we'll come back to. So when we started looking at live OTT, and you can say Net Insight, we're a company been working very much in the production environment and the professional media environment for over 20 years. We're doing a lot of the big contribution from the big events. We're also connecting all the bigger broadcasters and TV companies around the world more for their professional contribution and production environments. It's really doing the video and data transport for them. We started talking to them 4 or 5 years back, because at that time we started doing contribution over IP networks for quite some time, but more and more also we want a really low-cost contribution over internet. And a lot of those niche content that was low cost was actually meant to be distributed over OTT distribution, because it was lower cost on an end-to-end basis. So he said, then we started talking to them, and he said, we see if you could actually do what you do on the contribution side for the delivery side, that would be awesome. So we started talking to a number of our existing clients, whether it's operators, TV companies, production companies, and what were the problems with the live and the live OTT delivery. The obvious, of course, was the low delay, but after talking to many of them, they actually said, well, we could actually work with some delay. I'll come back to a couple of cases where you cannot. But very important for us is that everyone will see it at the same time. It's very hard to work if someone sees something 10 seconds or even 60 seconds apart from each other. And of course, you also have the non-harmonization between the normal broadcast delivery and the OTT delivery. So synchronized TV was very, very important for them. And of course, low delay. And of course, you have certain applications when you are actually on the event. There you really need, and you want to watch on your mobile or your mobile device. Of course, you need to have very low delay. You're also talking to someone like the betting industry. For them, lowest possible delay is of the highest importance. But otherwise, actually, when talking to the broadcasters, they said, we typically do not, because in the beginning we said, okay, we want to do the lowest possible delay, a couple of seconds, be even faster than broadcast TV. That's the goal. But when we talked to the broadcasters and the TV companies, said, no, not really. What we want is a seamless TV experience. If you can provide the same delays that we experience on the normal platforms, the primary screen, that would be the perfect fit. We'll come back to that actually when we talk about some of the applications. But as I said, also premium experience. This talked about the channel swap times, like in the early IPTV days. And actually, it's even worse on the OTT side. It can take 2 to 9 seconds to swap between channels. They also said when we're doing things like want to do picture-in-picture or picture, and picture, in the same screen. Again, the synchronization is very important. We can't have them unsynchronized. And of course, we want to have very resilient streaming. But very many times, they also come back to the fast channels change times. Not only just for the linear service, because they also said what we want to do is have multi-camera experiences. We want to have different camera angles. People should be their own producers. They should be able to choose their own content. So we want a new TV experience, not only do the same thing that we did on normal broadcast TV. We want an enhanced viewing experience on the second screen. And a part of that, of course, adding all the data and statistics, etc., but also to engage the audience and make them more interactive in their viewing experience. And part of that is then you need a very fast channel swap times. If you're adding, go between camera angles, that can't take multiple seconds. The last one is also interesting. We talked to a number of normal IPTV, cable TV operators, and they said, well, and it goes back to what Shannon said in the keynote speech. In 5 years, the normal broadcast will be over OTT. So yes, we strongly believe that cable, IPTV, and satellite over time will evolve more towards more OTT streaming environments. But you should remember there's a lot of investments being made in those metal set-top boxes sitting at the homes. And also for a cable or IPTV operator, they have invested in very optimized IP multicast networks. So for them, if everyone starts streaming their own, 1 or 2 or even 3 streams to every home, that will really put a lot of burden on their existing networks. So they said, well, the perfect thing would be if we could use the mobile devices as kind of remote controls. You work with them, but when you come down and sit home in the sofa, you cast it up to the set-top box. So have that fast, seamless casting, not only to Roku or an Apple TV box, but actually to the existing set-top boxes. That would be really nice. And then you can add a lot of things into the apps, like the curation recommendations that we spoke about in the last session. So when we're looking at a more optimized platform, okay, to reduce the delays, we have to both look at the client and the segment buffering we're doing there, but also at the packager. So when we're doing the most optimized streaming, we actually take away the segmentation, just work directly on the stream. Then a lot of people say, well, that sounds really good, but how can you then do the ABR profiles and work between the ABR profiles? Well, it actually works quite well. It's no problem at all to go between different, seamless to go between ABR profiles on a streaming service without segmenting the streams. And the typical delays you can come down to is, I think now we're down to 1.5 seconds with full ABR support. The other thing we do is we actually make sure that all devices have the same clocks and they show the content at the same time. So you get, in essence, full frame synchronization between all devices. So that requires that you also have a notion of time at the devices. So the typical time protocol today would be NTP. People start talking about PTP and IEEE 1588. So you can say that's something we also add to this, that you have the notion of time and you tell when devices are to show the content. And this way can make sure that everyone watches at the same time. The other thing is working on getting very fast up to high quality. But more importantly, we work with something we call stateful ABR. So when you have watching a channel on the device, well, we know what ABR quality that device is capable of handling. And the normal thing when changing to another channel is you go down to the lowest quality and you work your way up again. And that can be quite annoying when you're switching fast between channels. So what we did is we actually have, keeping the notion of what ABR quality we are at. You go down one level instead of going down from the start and restart from again. That again gives not only fast channel swap times, but you actually maintain the quality when swapping between the channels. So I think with that, I'll leave over to Matt. You can talk a little bit more on how you have implemented it.
Yeah, so at TATA, we've implemented the NetInsight Live OTT solution on our global backbone. If you're familiar with TATA or not, here's a representation of our Tier 1 IP network. You can see that it's truly a global network. The thick blue cables are actually owned and operated wholly by TATA, and the green are either consortium or partner cables. So it's truly a global IP network that allows us to serve synchronous live OTT globally, whether you're in the UK or in New York. Everybody can see the same thing at the same time and still be harmonious with whatever the local broadcast is. Here's an example of the signal flow as it traverses through the live OTT system within one of our data centers. Here it's pictured as a cloud. Those are virtual machines living within TATA data centers around the world, of which we have 44 around the world. So while it's a cloud, it's still owned infrastructure by TATA, so it's very easy to scale and turn up new services in either regions or scale within a region itself. Down at the bottom, you see that it's referred to as a CDN in this drawing. It's not typically a term that we use when talking about it at TATA because it's completely there's no caching involved whatsoever. So it's not a CDN as people traditionally think about it. While it still is a content distribution network, it's not a traditional CDN. So we often refer to it as a next generation CDN. So Here is a high-level deployment design of how we're actually deploying it at Tata. We have this demoed at our booth next door, and you can actually see some live video traversing out of our Crescix data center, which is represented on the top right. That's in the UK, outside of London. That site is actually on net and built today, and everything that we're looking at and demoing is being served out of there. There's an additional core node in Santa Clara, shown on the top left, that's going to be turned up next month to serve as the 2 core ingest sites for this managed service that we're going to sell that we call Live OTT. So there you can see each one of those ingest nodes are going to be capable of supporting 100 channels ingest on day 1. And you see they come in and they're transcoded in off-the-shelf standard transcoders, outputting traditional ABR type streams, and then ingested into the ingress servers at those sites. From there, they're sent out to various egress sites via the TATA Tier 1 IP network, which is AS6453, which was represented on that first global drawing that I showed you. So because all of these nodes live on our Tier 1 backbone, the delay is minimal, and we're also able to take advantage of all the world-class peering relationships that TATA has around the globe. So we can predictably deliver these streams. You'll see that on day 1, we'll have 6 egress nodes being deployed in North America. They're listed there on the bottom left. 3 egress nodes in Europe and 2 in APAC. And again, they're all residing directly on the Tier 1 AS6453 backbone to take advantage of the latency of that and the peering arrangements. This is an overview of the Tata Media Ecosystem, which shows how we can truly offer sort of an end-to-end experience, or glass-to-glass, as some people call it, from either whether it be a racetrack or a satellite feed. We have multiple teleports, several in India, one up in Canada, down in Cyprus. So we can pretty much see any satellites and put them into our network via our Video Connect product, which is our high-quality, high-bandwidth video contribution network. We can bring those feeds into the live OTT ingress, whether that's in Crescix or in Santa Clara, and then deliver them. On the bottom right, you'll see the green live OTT cloud, that we can deliver them anywhere they need to go via that method, or we can deliver them over traditional CDN or traditional OTT platforms. Within this ecosystem, you'll also see media storage, asset management, transcoding, things like that, that complement all of these all these other services. So, and one of the POCs that we are talking about that we've done was a partnership with Sky in the UK, who you're probably familiar is the DTH provider in the UK, and with Formula One. So Sky wanted to provide a complementary service to their traditional broadcast of the Formula One races, not to compete with their traditional delivery method, but to complement it. So what we did from Singapore in 2015 at the Singapore Grand Prix was picked up these feeds and delivered them over the live OTT infrastructure and brought them into sync with the Sky DTH Formula One Grand Prix feed for the UK. So a viewer at home is watching their Sky set-top box off of the satellite, watching the race, and can have a companion app on their second or third screen, whether that be their iPhone or their tablet, and can ride along with their favorite driver, toggle between drivers, all in sync or in a harmonious experience with the primary Sky feed. The second screen, it's great if you can ride on board with your favorite driver, but if it's not in sync when there's an accident or when somebody's passing somebody else, it's kind of useless. So what we were able to do is harmonize those feeds, and it's kind of interesting because Sky is a DTH provider, and the signals need to go to the satellite and come back down to your house. We actually had to slow down the OTT feed in order to bring it into harmony with the traditional feed, as opposed to the other way around, that people would often think that the OTT feed would be behind the broadcast feed, but you can see there the delay time that we had to work with. And that's how we're implementing this at TATA. So.
And I think this is quite interesting because there's a lot of money right in the sports rights. So for Formula One has sold the rights to Sky and other rights holders around the world. They don't want to compete and send the same content to the end users. But of course, at the same time, they want to have a direct connection. And that's, I think, a lot of the content owners today, and especially sports content owners, are struggling with today. Should we go direct and compete with existing rights holders, or how should we do this? And when they saw this, that was an excellent opportunity for them. They could add more content and actually enhance the viewing experience for the viewers and add all the driver cams, make them synchronized with the big screen. So when you actually are on the starting line, you follow your main driver, you go into the first corner, it really becomes like a play-like feeling. You can see a lot of people when they are demoing this, people start driving their iPads. Really game-like experience. And what they also think, which is good for the rights holders, this is actually driving people back because it's a more engaging experience. You're much more part of the experience, so you have longer viewing times, and it drives people back to the first screen as well. So it's really a win-win situation. So where the traditional model is you go from content owner to broadcasters to operators and consumers. And with OTT, you started bypassing the operators. And now even the content owners are going direct. This allows us to maintain the rights holder business model and just add a new revenue path with a direct path with an enhanced second screen. So it's really a win-win situation. I'll see if I can get a small demo so we can find before we end the presentation so you can see it. We don't have the Formula One content here today, but we worked with a company called Air Now that are doing a lot of race leagues here in the US. So this is a demonstration. It's actually recorded material, this, but we're using 5 different driver cams and camera angles that we are now streaming from the Cressex back in London. So this goes actually over the Atlantic, goes over the normal Wi-Fi here. So if you see some things, it might be that you are doing too much other things on this network. But this is interesting. What you can also do, you not only just watch your favorite driver, you can also put up 2 drivers like in a duel, side by side. You can see them compete directly. Again, requiring synchronized delivery of both streams. You see the thing notifications down in the bottom. That's something we also start seeing that, okay, now you put all the decisions on the end users. You as an end user becomes your own producer. But as producer of the content, you also want to provide narratives. So you can put up like small narratives or alerts that something happens. And of course, if you have something else, multi-camera experience like golf, that can be like a birdie putt is happening. You click on it and you directly goes into the action. So if something comes up, like a narrative, you click on it and you directly comes into the action. And you saw very fast challenge change times. You can also, in this case, go between internal camera angles within the car. And you can also do things like picture-in-picture. So you follow your driver, but you can see the in-car. And you can see the black car that they are synchronized the 2 streams there. Again, remember this is actually streamed out of Cressex in London. Goes over the Atlantic, and still we can maintain the synchronization between the streams. So it a little bit shows just the possibilities of having low delay, but also synchronized delivery of the OTT streams. So thanks that we make this session.